Okay guys, today's lesson is graphing linear inequalities. Graphing linear inequalities are almost identical to graphing linear equations. However, one of the main differences between inequalities and equations is that inequalities have a lot more solutions. As you can see on the left side of the page, we have all linear equations in slope-intercept form. Equations have equal signs. On the right side, we have linear inequalities. These two are in slope-intercept form, but as you could see, they are not equal signs. We have inequality signs. So what we're going to do is graph the equation first on the left-hand side, and then graph a similar inequality on the right-hand side. The first problem on the top left, our equation y equals 2x plus 1, we're going to graph by first graphing the y-intercept of 1 and using the slope of 2 to make our second point. Remember, slope, or m, is equal to the rise over run. It tells you how far up or down to go and then how far over to the right. Since the slope here is 2, from that first point that I just plotted, I'm going to rise 2, which means go up 2 units, and to the right 1. I'm going to go ahead and draw or graph a nice straight line through those 2 points, and that will be our linear equation, or the graph representing y equals 2x plus 1. If I were to ask you to name me an ordered pair that's a solution to this equation, y equals 2x plus 1, you would name me any ordered pair on that line. So you already have 2 points on the line, but any ordered pair on that line would be a solution to that equation. Again, inequalities are a little bit different because they have a lot more solutions. I'm going to go over to the right-hand side, and now we're going to graph the inequality y is greater than or equal to 2x plus 1. We are going to graph this the same exact way as the equation on the left, first plotting the y-intercept at 1, and then using the slope of 2 to go up 1, right 1 to make my second point, and graph the line. However, since it's an inequality, not only are all the ordered pairs on the line solutions to the inequality, but all the solutions above or below it are also solutions. Since this problem has a greater than or equal to sign, I know that the solutions are on the line and also above it. So the way that we're going to show the additional solutions to this inequality, or the additional ordered pairs that would be solutions, is we're going to shade the entire top of the line. Since we have a greater than or equal to sign, again, we know that all the solutions are on the line, plus all the ordered pairs above the line are also solutions. That is the difference between graphing an equation and an inequality. Let's go ahead to the second equation and the second inequality. Notice how they're very similar. The one on the left has an equal sign. So I know I'm just going to graph a line, and all the ordered pairs on that line would be solutions to the equation. We'll first graph the y-intercept of 2, and the slope in this case is -1, or -1 over 1, representing the rise over run. From that first point, I'm going to keep my pen or pencil on that first point on the y-axis. I'm going to rise -1, which means to go down 1. Run 1 means to go right 1. And that will be the graph of our equation. Again, if I were to ask you to name me any ordered pair that's a solution to the equation, you can name me any ordered pair or point on the line. Moving over to the inequality on the right, notice how it's basically the same problem, except now it's an inequality sign. This is going to have a lot more solutions. Not only are the ordered pairs on the line solutions, but also above or below the line. Let's first plot the line, starting at the y-axis at 2, using the slope of -1, down 1, right 1, and graphing our line. Where else are there solutions to this inequality? Is it below the line or above the line? Well, this is a less than or equal to sign. So the solutions will be less than or under the line, which would be on this side. So we're going to go ahead and shade this side of the coordinate plane, representing that these ordered pairs are also solutions to the inequality. When we have an equal sign, do not shade. The only solutions to the equations are the ordered pairs on the line. When we have an inequality sign, we are shading one side or the other, showing that there are more solutions. Let's go ahead and move on to our third equation and third inequality. This has a y-intercept of -2, so I'm going to put my first point on -2, and the slope is 1/2, representing the rise over run. From my first point, I'm going to rise 1, which means to go up 1 unit, and run 2, which means to go to the right 2 unit, and graph my line. For equations, we stop here. All the ordered pairs on the line are solutions to the equation, nothing more than that. Over on the right-hand side, we now have an inequality. We're going to graph this the same as the equation. However, one new thing that needs to be brought up is now it's just a less than sign, not a less than or equal to sign. Notice the first two inequalities have a greater than or equal to sign or less than or equal to sign, notated by that line under the inequality sign. Since it was greater than or equal to or less than or equal to, we graph the line with a solid line showing the ordered pairs are on the line in addition to above or below it. Since we just have a less than sign here, we're actually going to graph this line using a dotted or a dashed line showing the ordered pairs on the line are not solutions. It's only the ordered pairs less than the line that are solutions. So again, we'll start at -2 and use our slope 1/2 to make our second point. And again, we're going to represent this line as a dotted or a dashed line. So what I'm going to do is actually erase just a couple pieces here just to make it look dotted or dashed. Again, that means that the ordered pairs on that line are not solutions. Where are they? They are less than the line. Since it's less than, we're going to shade below the line, showing that all the ordered pairs below the line are solutions to the inequality. Our last example here, we're going to start at -1 on the y-axis, as that is the y-intercept, and use our slope -2/3 to make our second point, representing the rise over run. Since it's -2, I'm going to go down 2 from my first point and to the right 3. Graph the line. Since it's an equation, we do not shade. All the ordered pairs on that line are solutions. Inequalities, however, have more. Again, we just have a greater than sign here. So just like the third problem, the one above, we're going to represent this line as a dotted or a dashed line. So start at -1, down to right 3. This is showing that all the ordered pairs on the line are not solutions to the inequality. Where are the solutions? Greater than the line or above it, so that is the side that we will shade. Again, one of the main differences between equations and inequalities are that inequalities have a lot more solutions. Therefore, we show that on the coordinate plane by shading one side or the other. We're now going to use this idea to graph systems of inequalities. On the left side, we have equations that we learned last lesson. we're going to graph the two lines and see where they intersect to show the solution to the system. My first equation I'm going to graph in blue, starting at the y-intercept at -2. And that equation has a slope of 1, so from that first point, I'm going to go up 1, right 1, and graph my line. The second equation, I'll graph in pink, starting in the y-axis at +2, and this has a slope of -1, so we're going to go down 1, right 1, and graph our line. These two lines intersect at one very specific point, which happens to be 2, 0, in which we would say there is one solution for this system. There is one ordered pair that's a solution to both equations, which is the ordered pair 2, 0. Inequalities have a lot more solutions. So over on the right, as you could see, we now have inequality signs. Not only are we going to graph both, but we're going to shade both of them on the same coordinate plane. The area where the solutions are where the two shadings would intersect. So the first inequality I'll graph in red. Again, starts at -2, has a slope of 1, and since it's a less than or equal to sign, that will be a solid line. Where would I shade if it's a less than sign? I'm going to shade under the line, showing all the solutions to my first inequality is in this region under the line. The second inequality I'm going to graph in purple, starting at the y-intercept of 2 and using the slope of -1. This has just a greater than sign. So it's going to first of all be a dotted or dashed line, showing the solutions aren't on the line, but since they're greater than, we'll shade above it. For systems of inequalities, the solution is a specific area of the graph where the two shadings intersect each other. In this case, it would be this triangular region where the red and the purple intersect. Therefore, this is the area we're going to shade darker than the rest to show that that is where the solutions are to the inequalities, or the ordered pairs that are solutions to both of the inequalities above. Let's go ahead and check out the second system of both equations and inequalities. I'm going to graph the first one in purple, starting at 1 on the y-axis, and using the slope of 2 to go up 2, right 1, and graph the line. Equations we do not shade. The only solutions there are the ordered pairs on the line. My second equation I'll graph in green, starting at -2 on the y-axis. It has a slope of -1, so we will go down 1, right 1, and graph our second line. These two lines intersect at specifically one ordered pair, which is the ordered pair -1, -1. Therefore, there is one exact solution to this system, or one ordered pair that's a solution to both of the equations. Over on the right-hand side, let's go ahead and graph our inequalities. First one, starting in pink, has a y-intercept of 1 and a slope of 2. I am going to graph this as a dotted or a dashed line since it's only a greater than sign. The solutions to this inequality are the order pairs greater than the line, so we're going to shade above it. Greater than, more than, above. Let's go ahead and graph the second inequality in green, starting at -2 with a slope of -1, and this 2 will be a dotted or a dashed line since it's just a less than sign. Will I shade above the line or below the line? It's a less than sign, so I'm going to shade below the line, showing that that is where the solutions are to that inequality. The solutions to the system, however, is the region where the two areas overlap their shading. So what we're going to do is darken that area to represent that this is the area of all the ordered pairs that are solutions to both of the inequalities. Our answer here is this area of the coordinate plane. What I'm going to ask you guys to do is pause the video, try the third system of equations and system of inequalities. Once you get your answers, play the video to double check. Here are your answers for the last two systems of equations and inequalities. The first one, again, equal signs, we don't shade. These two lines intersect each other, but unlike the last two, they don't intersect each other at a perfect ordered pair. Therefore, we know there's one solution, however, we don't know exactly which ordered pair it is. Over on the right-hand side, make sure that the first inequality that I graphed in red is a solid line because it's a greater than or equal to sign. And the second inequality is a dotted or dashed line because it's just a less than sign. The area where the two shadings will intersect is this top right area that's darkened on the coordinate plane, which will be our answer. Please let me know if you guys have any questions on the lesson, and